All right, so this is the last part of 4-3, right?
Right.
Okay. You might need your calculator. I know I will. Why are we so giggly today? So getting out your calculator requires all of this noise, right?
Yes.
All right, so your homework problems will require a picture. You've got to draw a picture. Your let statement is your picture. So this, yeah, you got to draw. And trust me, nobody draws worse than I do. This was Mr. Gleason's attempt. This is Mr. Gleason drawing on the computer, which I thought was pretty good. Can you guys not talk while I'm talking? Come on, let's go. You're not the only one. All right, so here's a person on a cliff. This is a very popular type of problem, where you're on a cliff above, looking over water. There could be a lighthouse over here. There happens to be a boat. There's a plane, right? So when you're trying to determine angle of depression and angle of elevation, it comes from your line of sight. So this is the line of sight right there, going straight out from your eyeballs. If I'm going to look up at the airplane, isn't my sight elevated? So the angle of elevation is this angle right here. If I'm going to look down at the boat, my sight has gone down. Or people who look down at their feet, aren't they usually depressed? You can think of it that way.
Or didn't feel like a cheese.
Well, they could be. But that would be your angle of depression. Your angle of depression goes from the line of sight to where your new line of sight is. Okay? So it depends on what you're looking at and where you're going. So watch what we're going to do for these problems down here. So here I have a person stands 50 feet from the base of a tree. So I'm going to draw my tree.
Should our calculator be reading the degrees?
Well, we're going to talk about that in a minute. You're right, it makes a difference. Yes. So here's my tree. Here I am, right here. I'm standing 50 feet from the base of that tree. And it says the angle of elevation at the top of the tree is 71.5 degrees. Now, if they have not mentioned that your eyes are 5 feet off the ground, weird but true, we're going to assume that our eyes are at my feet. There's my eyes. I know, weird. But, I mean, technically, isn't this where my line of sight is? Right up there? Wouldn't you agree? And then if I look up at the tree, this should be my line of sight, and then I should be looking up this way. So I should have a right triangle up here off the ground, technically. Now, some of your problems are going to mention that your eyes are 5 feet off the ground. If that's the case, when you find this height from here to here, won't it be missing the 5 feet down here? So when you solve for x, you're going to have to add that 5 feet that your eyes were off the ground onto the rest of your answer. So that's the only thing that we're not doing here that you might see, but you should recall that from geometry, right? We did a lot of that in geometry. All right, but this isn't saying that. So like I said, I'm going to assume my eyes are at my toes. The angle of elevation to the top of the tree is, that's being elevated in that direction, right? So that's where my 71.5 degrees is. This is where my right angle is. Don't I have a right triangle? Isn't trigonometry based off of right triangles? So, what is it I'm trying to find? So this is x from here all the way down to here. Agreed? So that finishes off my triangle. So I have my degree, or my theta, and I have two sides of the triangle that I'm focusing on. According to theta, my degree, is this the side opposite, adjacent, or the hypotenuse? So I'm going to put opposite here, and what is this? Adjacent. Now, 100% of the time, and here you might want to write this up here at the top. Go all the way back at the top. All of these problems have either sine, cosine, or tangent of some theta. Sometimes you know the degree, sometimes you don't. Equals something over something. You're going to have two out of these three things here. You're going to have two of them. You have to figure out which one of these two you have. And then based upon these two items here, whether it's sine, cosine, or tangent. So you're going to choose one of these three, and you're going to have 2 out of those 3. So look at what we have down here. Sine, cosine, or tangent uses opposite and adjacent. Sine, cosine, or tangent. Tangent, right? TOA? Agree? So I've got tangent. Do I know my degree? Right there, right? 71.5 degrees equals opposite over adjacent. What's my opposite? X. What's my adjacent? 50 feet. Now, all I'm going to do is turn this into a proportion. And how do you solve proportions? Cross multiply. So we're going to cross multiply. What's 1 times x? X. And so x is equal to 50 feet times the tangent of 71.5 degrees. Now, Caitlin, ask your question. What are we putting into the calculator, degrees or radians? So what should your calculator be in? Degrees. So do double check your mode. So go to mode and make sure, see I'm in radians, so I want to make sure that I scroll over to degrees and make sure you hit enter, and then that's the only thing highlighted. So then go to second quit, and now we can plug this in exactly as it looks minus the feet into your calculator. So 50 times the tangent of 71.5 equals. Does it mention anything about rounding? No. So if it doesn't mention anything about rounding, what should we round to? We'll go to 2 places. So 149.4 what? 3. So it's approximately equal to 149 point, what did I say? 43 feet. So therefore, the tree is about 149.43 feet tall. Yes, it is. Nobody said the math person making up this question was thinking about reality. The biggest tree in Arizona just blew down in the last storm. Did I tell you this? Guess where it was?
Outside your house.
What's my least favorite city in the state? You should know this. Tucson. Tucson had the highest cottonwood tree. It was on the National Registry of Trees. Did you know that there was such a thing? There's a National Registry of great big huge trees, and that sucker blew down or broke in half or something. And I thought, poor tree. Poor tree.
How tall is it?
Don't quote me, but it was somewhere between 50 and 149 feet. I can't remember now.
Very long requirements you have to be on the list.
It was a very, very tall tree, yeah. Do you have a question? I think it's somewhere around that. It was several weeks ago. I don't remember all these details. Okay. Yeah, no more Twinkies. Did you just say that? Yes. Well, let me just say, note to self, see this is being recorded for posterity, note for self. If you are striking and your company says, I cannot afford to pay you more, guess what happened to all those jobs? You lost.
18,500.
Striking doesn't always get you a better deal. Just saying. In an economy like this, you're going to strike? Really? Are you kidding me? You should be thrilled you have a job. No, I'm striking because you're not paying me enough money. Huh? Well, that's because they're not used to actually working. The Greece is that way too. Well, I can understand why employees might be upset about Black Friday, because Black Friday has creeped, are you listening? Black Friday has creeped from starting at midnight to starting on Thanksgiving Day, and that's what they're upset about. They would like to have a holiday too. So they're not striking, and having a strike line, they're just protesting, there's a difference. I can totally support that.
Wait, Miss Murray, what do you mean like midnight to Thanksgiving Day?
Black Friday starts at midnight on Thanksgiving Day, okay, which is really Friday. But now they've creeped it up to starting at like right after dinner on Thanksgiving or on Thanksgiving Day. And what that happens is those people don't get to have a Thanksgiving with their families. Yeah.
I would have told you to screw it and no one should have shown up.
See, it used to be the big taboo that when I was your age, I worked at a grocery store. The grocery stores were not open on Christmas or Thanksgiving. And then when I was your age, all of a sudden, they started opening up on those days, and you would think that the world would come to an end. But now they're open 24 hours, aren't they? You don't hear anybody complain that they're open on Christmas and Thanksgiving. Why? Because they get double time. So usually it's a person's choice. Who wants to work Thanksgiving and Christmas? If they want money, they're going to start working. And if they don't get enough people to work, then you either have to work it, or there's just not enough people to help out. Yeah. Well, that's it too. What happens when you don't show up to your job or you call in sick too often? You get fired.
You were not here like half the week this night.
That's not true. I was here 3 days out of the 4, and the day I was gone, I was working mathematics.
You a lot, and then this guy started talking about the economy. Oh my gosh.
All right, so let's finish. Hang on. Let's finish our problem. You ready? Here we go. Shh. Person. Wait, listen. Person. You love this? Person. Like that's a name. So person is 200 feet from a river. Well, here's the river. Here's the river. Right here. Now, how do we determine, here is person. Right there. This is person. Well, who says person? A person. I must have missed the word A. So here's person. How do you determine the distance, because he's standing in a point. How do you determine the distance from a point? This is a line to a line. Think geometry. Thank you. Mike is thinking. So isn't the distance from a point to a line always a perpendicular distance? So I know without being told that that is a right angle. And they said that he is 200 feet, so this is 200 feet from the river. He does not walk straight to the river, but walks 400 feet in another straight path to the river's edge.
Who does that?
So, I don't know.
There's a bunch of rocks there.
He's meandering. Yeah, it could be a bunch of rocks. Who knows? Who knows? Maybe there's a pretty girl over here. I don't know. Sally?
Person over here.
Persona, yeah. So, this is his second. This is his second pathway. Right? He's just a boy.
His name is Person.
Yeah, that's right. What do you expect? His name is Person. All right. So it says find the angle, and this is important because you have to figure out which angle they're talking about. Find the angle between second path. I didn't write this. Between the second path and the river. So here's the second path, and here's the river. What angle are they talking about? This one right there, right? Because they said the second path and the river, right? So this is my point of reference. That's my angle of reference. So to that angle of reference is 200, the side opposite, adjacent, or the hypotenuse. So this is opposite, and what's this one? Hypotenuse, because it's across from the right angle, correct? So sine, cosine, or tangent has opposite and hypotenuse. Sine, do I know the degree? No, so that's theta. So this is why it's important to put in theta. Don't skip it. And then what over what? So 200 over 400. Can't I immediately, well, we are using our calculator, but can't I immediately cancel those out? And doesn't this is really 1 over 2, and if you've been memorizing things, you should know what theta is at this point, because the sine of what degree is 1/2. We hypothesize it's 30 degrees. Let's just do it mathematically and double check. When you don't know theta, how did I show you how to do it on your calculator? What are you punching into your calculator? Well, this is really the sine of theta is equal to 0.5, right? So whatever it is, you're going to find that fraction or that decimal, right? And then you're going to do the inverse sign, right? Of 0.5 equals theta, which in this case, if you don't believe Paris, So you've got the inverse sine of 0.5, or you could put in your fraction, is what? Looks like a 30 to me too. Would she have had to go through all that work for this particular one? No. So therefore, the angle is 30 degrees per person.
Look at you in person.